Hey everybody, hope we're having a great day. Today we are going to work with some square roots and we're going to simplify those square roots. So we're going to start off with some real simple ones here today. Let's just start off with the square root of 16. Now we all know that the square root of 16 is 4. But why is it 4? Well, it's 4 because square root means what number times itself is this number right here underneath the square root. So in this case, it's 16. Well, yeah, we've worked with this. We know that the square root of 16 is 4, but what if we didn't? What about when you're just starting off? Well, we've got some options. One option is trial and error. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. Hey, square root of 16 is 4. Works pretty great when we got a number like 16 that's not real big. We can just test them out and see what it takes to get to where we want to be. But what if the numbers didn't work out so nice? What could we do? Well, one way to work through this is with a factor tree. I like factor trees. So I'm going to break up 16. Well, 16 is 2 times 8. 2 times 2 times 4. 2 times 2 times 2 times 2. Okay, square root, number times itself. So that means what I'm doing here is I'm looking for pairs. So I look right here, and I see 2 times 2. I see another pair, 2 times 2. Great, I've got 2 pairs. So instead of writing the square root of 16 as 16, I'm going to write it as square root of, in green, I've got 2 times 2, that's 2 squared. And in red, I've got 2 times 2, that's 2 squared. Well, great thing about square roots, if it's multiplication inside, we can take that square root and we can break it up into 2 separate square roots. So I'm going to break this up to square root of 2 squared times square root of 2 squared. I broke it at that multiplication symbol. Well, we know that square root and squared, they're inverse operations. They undo each other. So I'm left with 2 times 2, which is 4. And remember, we started with the square root in the problem. It was there before we did anything. That means it's a square root function, and we only want the positive value. So we've got a method now to simplify square roots. Well, one that's a little bit different. Oops, wrong slide. What if I had the square root of a fraction? 32 over 50. Well, first thing I would want to do is I would want to try to simplify the value underneath the square root symbol, inside of that radical. Square root symbol is actually called a radical. Let's write that down. Okay, so I want to simplify 32 over 50, and, well, 2 goes into both of those. So I get 16 over 25. Nice. Now remember, 16 over 25, that's like 16 divided by 25. And if I think about what division is, we can rewrite division as multiplying by a fraction. Okay? So that means that division and multiplication should follow similar rules. So if I can break up my radical into my square root into 2 separate square roots, when it's multiplication between my 2 values, I should be able to do the same thing when it's division. And what that means is I can break this up to square root of 16 over square root of 25. And we just calculated the square root of 16. It's 4. And we know that the square root of 25 is 5. And we've got a value for our square root of 32 over 50. I'm going to stop this video here. I'm going to go to and do a couple examples right off of your assignment, but I want to leave those separate so that you can go back and kind of watch this in pieces.